So the equation 8x cubed minus 27 equals 0 has 3 roots. Because it's a cubic function, it should have 3 roots. We want to determine how many are real, what are they, and how many are non-real. So we did just factor this. It became 2x minus 3 and 4x squared plus 6x plus 9. So if we set that equal to 0, we can set each of the terms equal to 0. So here 2x is equal to 3, x equals 3 over 2. So we have one real solution. We also have 4x squared plus 6x plus 9 equals 0. Now we already know that that quadratic is irreducible. We can't factor any further. So that means we'll want to use quadratic formula. So x is equal to negative b plus or minus square root of b squared, which is 36, minus 4ac, so 4 times 9, which we'll get minus 144, all over 2 times a, which is 8. So if we notice here, under our square root, we're going to get a negative number. So that means we're going to have non-real solutions here. So we found that we should have one real solution, which is x 3 over 2, and then we'll have 2 non-real solutions. So let's try some more factoring. Looking at number 6 here, we first always look for a common monomial we can pull out. We can pull out a 5x. We're left with 8x cubed plus 1. Now inside here, we actually have a sum of cubes because 8x cubed is 2x quantity cubed. 1 is 1 cubed. So using that rule, our first thing we take our terms and add them together, 2x plus 1. We square the first term, so that's 4x squared. We'll subtract, again the sign is opposite, their product, so 2x times 1 is 2x, plus second term squared, 1 squared, which is 1. So this would be our final factorization. In B, we've got another, this one's a difference of cubes, because 8x cubed is, again, the quantity 2x cubed. I always think about it as negative 64 is negative 4 cubed. So that way when I write it out, I'll get 2x minus 4, my two terms there. Then I square the first term, 4x squared. I take the product of the second and change the sign. So it should be 8x, negative 8x, we're going to make it positive 8x. And then the second term squared, negative 4 squared, is plus 16. And that is our factorization. 6c, this one's another sum of cubes. Trying to practice this. 27x cubed is the quantity 3x cubed. 64 is 4 cubed. So the rule says we take them and add them. 3x plus 4. The first term squared, so that's 9x squared. These are both positive, so we change the sign. Subtract the product, 3x times 4 is minus 12x, plus the second term squared, plus 16. Now, 6D is kind of a hard one to recognize. The key here is that both of these are perfect squares. 16 is a perfect square. 16x squared is a perfect square because it's 4x squared. 9 is a perfect square because it's 3 squared. So this actually is 4x plus 3 squared. It's a perfect square trinomial, and we can double check it if we were to take this and multiply it by itself to square it. We'll get 16x squared, outside terms plus 12x, inside plus 12x, last plus 9, and it works out. So this is kind of one you just have to recognize, and it's definitely harder than some of the other ones, but if you notice the first and the last terms are perfect squares, there's probably a good chance that it's going to be a perfect square trinomial. Factor by grouping, we've done this before. You take the first two terms, factor out what you can, take the second two terms, factor out what you can there, and then group them together. So we'll have x to the fourth and x cubed grouped, x plus 1 grouped, factor out what we can. X cubed. X cubed. Yep. And then a 1 here. So we'll get x cubed plus 1. Now, if you notice, this is a sum of cubes. This x cubed plus 1. So The terms are x and 1. So first term squared is x squared. 1 times x is just x, and then plus 1. So notice we've got this twice. We'll have x plus 1 squared, and then x squared minus x plus 1. So factoring by grouping, we're going to group these terms, we're going to group these terms. What can we pull out of the first one? An x squared. We're left with x plus 3. What can we pull out of the second one? It's a 3, so that we're left with, again, we want that x plus 3. So then grouping our terms together, x squared plus 3 times x plus 3. And there's our solution. Over here, we're going to group them this way. What can we pull out? An x squared, we're left with x plus 4. So since we want our other term here to be x plus 4, we need to pull out a negative 1 so that if we were to redistribute, it would get the minus x minus 4. So that means we're left with x squared minus 1 and x plus 4. Now, we're not finished because x squared minus 1 is our difference of squares. So we can actually factor that further to become x plus 1, x minus 1, and then keep that x plus 4. And now we have finished factoring.